This is a Mimi HQ video on why architectural governance must be model independent and outlive every model swap. Welcome back to another explainer. Look, if your team is building with AI-assisted development tools, you already know firsthand how incredibly fast the landscape is shifting around us. But with all that unprecedented speed comes a massive, hidden structural risk to how we govern our code. Today, we're going to unpack exactly what that risk is, what it looks like when it causes a critical failure, and how to build a structural system that fundamentally solves it.
This is a Mime HQ video on why architectural governance must be model independent and outlive every model swap. That core maxim is exactly what we're exploring today. Because if your governance doesn't outlive your tools, you're not actually building an architecture, you're really just renting a temporary workflow. Think about it. When we tie our security standards or architectural intent to whatever execution engine is currently trending, we are practically begging for those standards to vanish the moment we upgrade our stack. That's a vulnerability no serious engineering team can afford to accept, and it's absolutely crucial we address it for the long-term health of our code bases.
Here is our roadmap for today. First, the AI governance problem. Second, the 5 roles of AI development. Third, hidden governance lock-in. Fourth, the repo as the system of record. And finally, the Meme HQ's structural solution. Okay, let's dive into this.
Section 1. The AI governance problem.
Right now, the AI tooling ecosystem is an absolute tornado. The model your team used back in March is almost certainly not the model you're going to be using in November. The IDE you lived in last quarter? Yeah, probably not the one your developers will demand to use next quarter. And that agent runtime spinning out code autonomously today? It's going to be entirely replaced in a year. Everything is in constant motion. To understand why this is such a profound risk, let's look at a familiar software infrastructure analogy. In traditional engineering, we universally agree that authentication rules don't live inside one single HTTP client, because if they did, swapping a client would mean losing our auth. Database schemas don't live inside your ORM, and your security policies certainly don't live inside a single CI runner. Why? Because the rule has to outlive the tool. Imagine a junior developer spinning up a brand new, experimental agent that completely bypasses a security rule simply because that rule was hard-coded into your old IDE. That is a critical data exposure waiting to happen. Tools turn over constantly, but the architectural rules of your system are the pillars that absolutely have to stay standing.
Which brings us to a crucial foundational concept. Model-independent governance is the property that architectural rules are not embedded inside one model, prompt, IDE, or agent runtime. I really want you to ask yourself, if a specific agent runtime your team loves right now is deprecated tomorrow, does your compliance and security posture just disappear with it? Do your architectural decision records suddenly stop being enforced? If the answer is yes, then your architectural rules are dangerously coupled to the fastest turning gear in your tech stack.
Let's move to Section 2. The 5 roles of AI development. To really fix this problem, we've got to look closely at the modern AI-assisted workflow and break it down into its component parts. Any modern flow essentially has these 5 distinguishable roles. First, the model, which is just the execution engine generating candidates. Think along the lines of a GPT-4 or a Claude. Second, the agent, which acts as the operator sequencing the actual work. Third, the IDE, which is merely the surface where the human watches and steers, like Cursor today or whatever completely new interface emerges tomorrow. Fourth, the provider, the API hosting the model, which teams migrate between constantly based on shifting costs or latency needs. Notice a trend here? These first 4 roles are deeply transient. In fact, their transience is a feature, not a bug. They are explicitly designed to be swapped out as the technology rapidly evolves. But there is a line drawn in the sand here. There's only one true system of record that absolutely must outlive those other 4 roles. It is role 5, the repository. Your repo is where your code base lives. It's where your architecture decision records, your ADRs are stored. It's where your security policies reside. If these foundational elements start migrating up the chain and taking up residence in the transient roles above, like hiding inside an agent's prompt file, well, your governance shatters the exact moment you switch agents.
Section 3. Hidden governance lock-in.
Everyone in the tech space loves talking about lock-in when it comes to AI, but they almost always mean provider lock-in. Now, provider lock-in is highly visible. It lives right at the API level, and quite frankly, it's mostly a solved problem thanks to multi-provider routing and fallback chains. But governance lock-in? That is entirely hidden. It operates at the rule level. If your architectural rules are model-coupled, your fancy API routing doesn't help you at all. Think about the reality of what happens when you want to change tools in a model-coupled system.
It means facing a brutally expensive rewrite. We're talking about literally pausing feature development for weeks just to re-encode all of your core architectural rules to make them compatible with a brand new agent or IDE. That's not just a nuisance, it's a massive hidden continuity risk that drains resources and totally tanks developer velocity.
Now, what's really interesting here is the striking contrast between adjacent concepts that teams often confuse with true governance. It's basically an open book on one side versus a locked gate on the other. Things like a cloud.md file or an agents.md file are just like that open book. They are model-coupled by design because they live in a specific runtime's prompt loading. And yeah, sure, they are highly useful for giving a model context, but they absolutely do not produce a deterministic binary verdict at the CI gate. If a model hallucinates and ignores a markdown file, a bad commit still slips right through. Similarly, an LLM wiki is just a knowledge surface. But true model-independent governance? That acts as the locked gate. It is a strict control surface. It doesn't just suggest the rules, it enforces them deterministically, flat-out refusing to let non-compliant code merge, regardless of what generated it.
Which leads us to Section 4, Repo as System Record.
So, the crucial point is, if we accept that governance must be a deterministic control surface, how do we actually guarantee it works across the board? Well, follow this enforcement path across these sequential steps. True model-independent governance guarantees the exact same verdict across all environments, and it is entirely testable. Let's say we have a rule, ADR 007, about database access. A change that violates ADR 007 at the very first step, the pre-tool use hook in something like Claude Code, will definitively fail. It will then fail at pre-commit on the developer's local machine. It will fail at the CI gate, and it will undeniably fail the PR check. It simply does not matter which shiny new agent opened the pull request or which frontier model generated the code snippet. The verdict remains perfectly consistent because the evaluation engine is consulting the exact same repo native corpus every single time. This kind of consistency is exactly what builds real trust within a fast-moving dev team.
And finally, Section 5, the Meme HQ Structural Solution.
Here's how that structural fix operates in the real world. MeManyHQ implements this exact structural architecture by acting directly as a repo-native control layer. Think of this as building an absolute fortress right in the center of your workflow. Instead of scattering your rules across a dozen different agent prompts, your architectural intent is encoded exactly once in a version-controlled corpus living right alongside your code. When a developer or an AI agent gets to work, that intent is retrieved through a deterministic scoping layer long before agents even generate the code. And then it's validated all over again at the hook and CI levels afterward. Because the rules live squarely in the repo and are evaluated by a rigid, deterministic engine, they inherently outlive the next model migration. They outlive the next trendy agent. They outlive the next IDE swap. MeManyHQ essentially transforms what used to be a terrifying multi-week governance rewrite into a simple, frictionless runtime change.
When tools turn over faster than ever, your architectural rules must stand firm. You literally cannot afford to rebuild your entire compliance and architectural strategy every time the AI ecosystem shifts. So ask yourself, is your team building governance for the specific model you happen to be using today? Or are you building a rock-solid foundation for the entire ecosystem you'll be navigating tomorrow? MeManyHQ, Architectural Governance for AI-Assisted Development, mmehq.com.